This is the first of a three-part demonstration of how to debug a Scala service with a slow actor leak that was traced ultimately to a race condition of unusual timeouts. This first part is how to set up networking from a Mac notebook using a SOCKS proxy and the appropriate JMX authentication. The second part is a quick view into a few VisualVM plugins and retrieving a heap dump for local analysis. And the third part is using the heap dump to work upwards to find the leaked resource and identify the fix to the actor's Scala code. It is a screen recording from a demonstration. Let's get started. So this Engineering Tech Talk is about a demonstration to show you how to do memory debugging using VisualVM, which comes with the JDK. And we're going to show how to install and then connect to, create heap dumps, pull them back, and analyze for the Einstein application, which was having a leak of actors that we needed to figure out what the problem was. So in Einstein, I've created a little directory called miscellaneous. The first thing to note is that there is such a thing as JVisualVM. Let me create another bash shell. And if you just type JVisualVM, it actually is on your path if you have the JDK installed. I have an alias that I dug up on the net to set the JDK version. I'm going to set it to the 1.8 version of Java because that one can actually do profiling, what's called snapshot profiling of memory in addition to CPU. These two macros are used to set the JDK version. So if we run that, then I can say set JDK 1.8 becomes version 1.8.
So you have both versions installed on your computer?
Yes, I've got 1.6, 1.7, and 1.8, all three installed. 1.8. Now if we say JVisualVM, it's going to pick up the version from 1.8. So if I say which JVisualVM, shows that. Okay. So this runs it. I don't know of a way to make this magnify.
You're going to provide the extra memory that you need later on the command line.
Ah, good point. Thank you. So you run it. In this case, we're upping the total amount of memory for use by the JVisualVM by adding the Java options to it. Passes through the script. MX 5 gigs, MS 1 gig. The place that we want to debug is actually, in this case, the Einstein instance. So I'm going to SSH to it. Oops, I already took that out. I'm being lazy and just grabbing it with copy-paste. This is the service in AWS that we're going to connect to. So in this, we have running, if we take a look, it's hard to see with this expanded one, but this is the actual Einstein process that we want to take a look at. You can see it's on 9001. It's got 12 gigs of MS and MX. That's interesting. So that's one we want to profile. The first thing you have to do is to set up a JSTAT daemon on the remote end. So that's done by doing two things. And you have to create a tools policy that grants access and permissions for the local JSTAT daemon to connect up. You just create a file like this called tools policy, and then you run the JSTAT using it. I'm going to show actually it's already running on this instance. I didn't want to rerun it. Oops, I had stopped it. And you have to run it as the owner of the process. So this was done with sudo -u Einstein, because that's the owner of that process, as we saw in the htop. We run jstatd, telling it the security policy to use is the security policy. That creates a proxy for the stat daemon, which allows us to then connect up to various services or JMX endpoints within this JVM, within this actual this node, this virtual machine. So that's set up. Our remote end, or sorry, our local end, I'm going to leave that machine that's already set up, is now got to actually forward to it. I'm going to create a little, I'm going to create another little instance, sorry, another window. I'm going to use what's called a SOX proxy. I'm going to put it on port 1080, which is the relatively established default port for SOX proxy, and I'm going to connect up to that instance as a SOX proxy. So this is connecting our networking from the local machine 127.0.1 localhost to that other computer.
So what 1080, where did you get that number
It's a default number.
for SOX proxy?
Yeah, you could pick any
You could
port.
pick
Any
10.1.
port you want.
Okay.
It's above 1024, so we don't have to be root.
Is that what you declare the jstatd also?
No, this is independent.
Oh.
The SOX proxy is at the networking layer, and we're going to connect through the SOX proxy to that JSAT.
Okay.
Okay?
So
Right.
since it's a random number, what's the use of that port number? Because nobody ever knows about that number, right? Nobody seems to know about this number. Normally a port is somewhere you connect to, somebody connect to.
It's
right?
on the local machine, forwarding to that remote Einstein node.
Right.
The only importance was that is that on a Mac, we actually have to explicitly and manually connect to that SOX proxy. You do that by bringing up your network preferences, going to advanced, go to the proxies, and then turn on the SOX proxies, and the number that is used, whatever you used in that previous command to set up the SOX proxy is what you want to enter here.
Okay.
If you look at the IANA, the Internet Assigned Number Authority, it defines 1080 as the SOX proxy port.
All right.
But you don't have to use that.
Okay.
It's just convention.
Okay.
So I just applied that, and I don't know, it gives some various failures, but it doesn't really affect VisualVM. Okay, so now VisualVM, if we go back to it, we can now add our host. This is kind of a recipe. And what I'm going to do is go to that machine and type ifconfig, grab its private IP address, and the remote host we're going to connect to by number, because that's what the SOX proxy is forwarding, and I'm going to give it its name that corresponds to its logical name. Oops,
Now
I can
this
copy
is the
paste.
external IP of the Einstein instance.
Yes. Well, it's the internal IP.
Is this the internal IP?
How are you able to connect to it if it's an internal IP?
The SOX proxy is what's forwarding. Let me show you that again. Here we are on that machine, and I said ifconfig. Whoops, ifconfig. The Ethernet 0 is on inet address 10.237.225.31. That's its private IP inside of Amazon EC2. It's not the public IP, which this machine can't even see.
I don't understand SOX proxy enough to get how that works.
It's just a mechanism to be able to connect up via SSH to the private IPs visible on that host.
Oh, okay.
It's a VPN Lite
Oh, all right.
in some sense.
VPN-ish, that's what we
It's like a VPN.
But you only need one port, right? So you could just port forward this and connect to the local host.
You could do that. But the SOX proxy will let you connect to any of the
Any port.
ports on that local host.
All right, all right.
Okay. So now we go back here to VisualVM, and in here I gave it the name of the instance that we're connecting up to. That's its git hash, or its unique hash code within EC2. At least that. So it's already monitored, so I guess I had already defined it. This is a, there we go, applications. Great. Obviously, it's the first time I've used it for this particular debug session. So here's the defined remotes. I was last using it on FFC, and now we're looking at it 8E8. That's the current one we want. So we double click that. Can add a JMX connection from it. I'm going to rerun Visual. Now, VisualVM, I'm going to quit and restart it because I turned on the proxy afterwards. So there, now it populated. So the JSTAT daemon that's running remotely on 8E8 automatically is populating the Netty server associated with the PID 16671, which we go back over to that HTOP or rewind back to where I showed it. That would be the process of the JVM that we're going to debug. If there were more than one, we'd actually see more than one here if they're owned by Einstein.
So JSTAT-D just connects to all JVM.
It's kind of a JMX proxy, JMX being the remote procedure call interface of Java.